Hi, welcome to today's lecture in software engineering series. In this session, we will review black box testing. Together, we will explore key topics including graph-based testing, boundary value analysis, BVA, equivalence, class partitioning, ECP. Let's do it. Introduction to black box testing. Black box testing focuses on the external behavior of the software without delving into the underlying code. The tester is concerned only with the system is supposed to do and how well it does it from the user's perspectives. This type of testing is crucial to ensure software meets the requirement of perform correctly and in real-world scenarios. Today we will diving into the three powerful methods: graph-based testing, boundary value analysis, equivalence, class partitioning, which help to identify issues related to input handling, state transition, and boundary condition in the system. Graph-based testing methods. Graph-based testing method is visual representation of how a system or application transition from one state to another. This approach is especially useful for systems with multiple states or decision points, like workflow systems or navigation within apps and websites. The system states are represented by nodes, and the transition between them are shown as edge. This helps testers ensure that all paths are covered and no part of the system is left untested. Application of this method includes verifying the functionality of menus, button interaction, or in website application where user can navigate between different pages or actions. It is also helpful for detecting unreachable states, ensuring that no part of the system is isolated and inaccessible to user. Boundary value analysis. Boundary value analysis is essential for finding defects that occur especially at the edge of input range, as these are often overlooked in standard testing. Since systems frequently fail to boundaries are the first and last acceptable input, BVA helps ensure that the system handles such cases correctly. For example, in application process gap into between 1 and 100, BVA would test values like 0, 100, and 101 to verify the system's handling of boundary conditions. BVA is critical for numerical range such as dates, age, or any other data field that have set limits. It helps catch those snaky errors that might only occur at the extreme ends of data input. Equivalent class partitioning. ECP simplifies testing by grouping input that are expected to behave the same way into equivalence or classes. Instead of testing every possible value, ECP allows tester to choose just one representation from each class of input, significantly reducing the number of test cases while still achieving comprehensive coverage. For instance, if an application accepts an age between 1 and 100, values within this range can be grouped into valid equivalence classes, 10, 50, 100, and invalid ones, -5, 0, 101, for example. By testing just one value from each class, you save time and effort while ensuring that all important behavior is tested. This method is particularly useful for systems that accept large input range or different type of inputs with similar expected behavior. This one, the age limit 1 and 100, and then we have a valid or invalid data. Comparison of methods. Each of the method we have covered several different purposes and is most useful in different testing scenarios. Graph-based testing ensure all possible paths in a workflow or system with the multiple states are covered, and it helps detect any reachable or faculty states. Boundary values analysis is primarily useful when dealing with the input limits such as numeric range or other fields where there are clear start and end point. It helps to catching edge case error that may not be evident with regular testing. Equivalence class partitioning is the most beneficial when the large input data input domains and want to minimize the number of test cases. By grouping input the similar behavior together, you reduce redundancy in testing while ensuring the key behaviors are covered. The real power comes in combining these methods. Graph-based method for state transition, BVA for boundaries condition, and ECPs for general input validation. Together, they provide a comprehensive and efficient approach to black box testing. Takeaway: combine these methods to ensure robust test coverage for both functional, correctional, and edge case handling. In conclusion, black box testing is essential for confirming that the system behave are intended and meet user expectation. It focuses on testing the system external functionality without knowledge of its internal working. By applying method of graph-based testing, boundary values, or equivalence class partitioning, tester can ensure comprehensive coverage of both general system behavior and potential edge cases. Combining these techniques help minimize the risk of missed defects and ensure the system functions correctly across all scenarios. Thank you.